Hey everyone, today we are going to create a reflection agent. Okay, so what is the reflection agent? So for that, first we need to understand what kind of problem our reflection agent will solve. Okay, yeah, so let's start. So you interact with a lot of AI agents, okay, and you ask them to write a code, whatever. Okay, yeah, and multiple times agents make a mistake. Okay, yeah, and of course when agent make mistake you always correct them. Okay, like you ask them write a code for this. Okay, and he use a function which is not supposed to be used. Okay, which is not a better way, so you just correct them like, hey, please don't use this, it's a harmful for my system or anything. Okay, yeah, this, and after that you will get the correct response. Okay, yeah, okay, so now as of now everything is fine. Okay, but after sometimes you ask the same type of question. Okay, again, so what happened, it your basically agents made a same mistake again. Okay, and you can see after some time, maybe after some day you will come and you can see if you ask the question like same again, and it will give a it will made a same mistake again and again. Okay, suppose it will gonna frustrating. Okay, yeah, so today we are going to fix that. Okay, yeah, how we can fix, we will create a reflection agent. Okay, so what is the reflection agent? So basically we are going to give our reflection agent a long-term memory. Okay, using Mem0. Of course now we have a lot of information. We already used Mem0, we have our Mem0 setup, we used our basically we also have our graph databases. Okay, we use Neo4j. Okay, so now we have a lot of information, lot of knowledge, we can create a multiple types of agents. Okay, yeah, so today I am focusing on the only reflection agent. Okay, yeah, we already built a lot of agent. Okay, yeah, so yeah, but today I am going to create a reflection agent which basically store our data for a very long time. Okay, some a month, after some months, some days, some couple of years. Okay, yeah, we will gonna store the memory for the long term. Okay, yeah, okay, so usually what happened, you ask a question to LLM. Okay, that will give a response and you will get, okay, directly. Okay, there is no intermediate things happen. Okay, yeah, but our agent will do something else. What happened, once like we ask something our agent, okay, it will give a solution. Yeah, of course we will get a response. Okay, but that will not show to the user. Okay, that will act as a draft only. Okay, that is draft. The second, we will critique. Okay, we will critique, basically he is find errors itself. Okay, he's trying to find like if he made any mistake of the solution. Okay, he will try to find the errors. Okay, yeah, and again by itself he will basically refine that work. Okay, so the third is the refine, and the fourth, what we are going to do, whatever mistake in the first time our AI made. Okay, or agent made. Okay, yeah, let's see ask a question. Okay, hey, write a code for this. What happened, he uses some like harmful command. Okay, okay, so in that case the critique, okay, the second basically the second step, okay, the critique, it will basically find the error, whatever mistake it's done, it will find that mistake. Okay, the third step, it will refine that step. Basically it will refine those errors. Okay, basically it will gonna fix that. Okay, yeah, of course now our LLM know what mistake he made. Okay, and that mistake will be stored into our Mem0. Okay, for the long term memory. So if you comes after some times, after some days, okay, so what happened, if you ask the same time after the question, in that case you will get the correct answer directly. Okay, yeah, okay, I think your AI will not basically behave like a first question. Okay, like a same question again and again. Okay, you will get the correct one very fast, and it's a very best way. Okay, yeah, so by the end of this video you will have a Python script for an agent that actually, of course, it's a very smart. Okay, yeah, okay, so let's start. So I think I already give you a very high level architecture. Okay, yeah, of course. So what happened here, yeah, I already told like there is a multiple step. The first is draft, second is the, you can say, the reflex agent, it will reflect that. Okay, yeah, and the fourth we can say refine, it will refine, and then next one we will get the final result. Okay, yeah, so simple. I just assume the second is the critique. Okay, but critique. Okay, I already always made a mistake to say critique. Okay, yeah, Nehru. Okay, no issue, sorry. So what happened here, the first step, you just drop that answer. Okay, agent try to answer. Okay, what happened, the reflection agent, okay, added a feedback loop. Okay, we are going to create a feedback loop. Okay, what happened, it's like our AI will have its own editor. Okay, so what happened, it will get the response, it draft it, it will reflect. Basically the agent pause for the some time and play. Okay, it looks for the security flaws, bugs, or bad logics. Okay, whatever he made a mistake. Okay, what happened after that? He will refine the agent, rewrite the answer based on the critique. Okay, basically whatever mistake, whatever error he is having in the first time, so this is called the reflection pattern. Okay, these all the basically all together: draft, reflection, refine, retrieve, basically critique. Okay, all those all together called a reflection pattern. Okay, and again it's a very powerful. Okay, yeah. Okay, and the best part is also or the memory. Okay, we are going to save our memory, okay, to our vector databases for the future edge cases, basically for the future usage. Okay, yeah. So what happened? Let me like if we ask any kind of question. Okay, if like our agent learns that a evaluate function is bad in Python. Okay, let's just take it as a like eval function is a very bad in Python. Okay, so it should never use it again. Okay, yeah. So in this scenario, our Mem0 comes in. Okay, we will store these lessons in a vector database. Okay, of course I'm going to use Qdrant. We already have our configuration ready. Okay, also and graph database for the relationship. Okay, yeah. So these things already we have. Okay, so before the agent we will okay, yeah. So before our agents okay, yeah. Okay, so what happened? Okay, before the agent give you response, it will check in the memory like if he learned about this topic before anything else. Okay, if he learn anything about this topic, then he is going to use that information and we and give the answer very correct. Okay, yeah, simple. So let's see, I already write a code. Okay, entire code you can see here. Basically a lot of things we can take it from other files. Okay, like in last video we build a multi-hop agent. Okay, in that case we already have our configuration ready. Okay, you can see we install our okay, it's nothing else you can see. Okay, let's see what happened. We can take it a lot of things from here. Okay, we need Mem0, we need OpenAI, we need .env. Okay, everything. Okay, and we need it's a complete configuration here only. Okay, yeah. So that's why I take it completely here. Okay, you can see here I just copy from there and paste it here only. Okay, yeah, you can see there's a configuration, there is nothing change. Okay, the embedder is same, LLM is same, graph store is same, vector store is same, only the change is our reflection agent. Okay, yeah, the logic will change after this only. Okay, yeah. So you can see when our program is running. Okay, you can see it starting running. You can say the name is a main. Okay, whenever we start this application, what happened? The reflection agent will call. Okay, simple. Of course the reflection agent will call. So in that case what happening, you can see, let me just show you. Okay, this is the okay, this class. So what happened, it's the initialize, basically it's a initialize the reflection agent with the Mem0. Okay, of course we need to initialize our memory first. Okay, yeah, you can see there is self.client. I just store the OpenAI here. Okay, for the LLM call I create a user ID for the reflection agent beyond. Okay, you can make it dynamic too. Okay, yeah, simple. There is some couple of functions available here. You will see. Okay, later, no issue. So you can see here the reflection, everything is available. Okay, so yeah, that's good. So after this okay, after this what happened here, this function basically our agents will basically initialize. Okay, yeah. After that I have a task query. Okay, yeah, I have added an example like writing a secure Python function. Okay, I already told like the if consider our agent will consider like a evaluate function is a very bad function inside our Python, so it will never gonna use in the later responses. Okay, in the later query. Okay, yeah. So uh, this is responsible for the initialize our memory. Okay, yeah, simple. After that we will take a basically query from the user only. Okay, yeah. So okay, let me just quickly remove this. Acha, okay, no, okay, it's good. So what happened here, running agent on the task. Okay, that's simply I just print the task query, and here I am just running agent dot run with the run function where we need to pass the query. Okay, so let's see our run function. So you can see what happened first I'm taking that memory. Okay, maybe I learned something related to this memory in my past. Okay, so for that we need to first extract that context from our DB only. Okay, so in this case you can see here I'm just getting those memory from here. How it's gonna take, you can see it. Simply I need to just add a search task. We need to pass the user ID here, and of course I'm adding a limit 3. Okay, you can add as many as limit. Okay, like you can add limit 10, 12, 20. It's up to you totally. Okay, and we already see this how we can basically iterate on the memories. Okay, yeah, we already build a lot of basically agents, and we use a lot Mem0. Okay, yeah, so we already know the clear understanding about the looping in these things. Okay, yeah, so this function is responsible to take the memory from the past learning, okay, from our vector database. It's simple. Okay, so let me just open this. Okay, yeah, so in this first we will get that memory. Okay, you can see also we would be needing. Okay, after that we will generate our draft. Okay, how we can generate? We need to provide our task and context. What is the task? So task is the query which is given by user only. Okay, and the second one is the context. The context is which we are getting from the database only. Okay, yeah, so let me just open generate. What happened here? Generate an initial draft based on the task and memory. So you can see here it's a simple print statement. I just make a prompt. You are an AI assistant, your task is this, and the you basically past lesson learned memory. Okay, and I just make a LLM call here. Okay, the role is user, the content is prompt. Okay, simple. In this prompt, basically I have, this is my system prompt. Okay, so yeah, now I'm getting the response only. Okay, so from generating draft, you can see here I'm not returning to the user response still. Okay, I'm just getting the response and make it as a, just treating as a draft only. Okay, yeah, so let's go to here. Okay, you can see here. Okay, after that I'm getting draft. Okay, what we need to check? We need to the reflect. Okay, all those critical. Okay, whatever mistake it's made. Okay, that thing we will get. So again I am just passing the task. Okay, whatever task, whatever query is given by user, and that draft. Okay, whatever response we are getting from the LLM. Okay, so again, okay, sorry, okay, let me just quickly open the reflect one. Okay, you can see I'm getting the self. Okay, this is the entire internally only we need to pass this, and you can see the task and draft. Okay, okay, no worry. So what happened here? You can see the step 2. What happened? Criticize the draft to find the error and area of the improvement. Okay, so I just made a prompt here. Again, a system prompt. Review the following draft for the task this. Okay, the draft is this. Simple. Identify any specific error, security issues, or inflation. Be critical. If it's perfect, say no issue found. Okay, simple. I just make a system prompt to find the errors. Okay, simple. And again, I made a LLM call. Okay, yeah, and we'll get the response. So let's, what happened? Okay, let me just go here. You can see now I'm getting the all those problems, basically all those mistake which done by the LLM in a first time. Okay, yeah, then you can see the final version we just refined. Basically we are going to solve all those problems, we are going to fix all those problems what which made by the LLM in a first time. Okay, so for that we need to pass the task, we need to pass the draft whatever we are getting the first time, and what mistake he made. Okay, simple. You can see here in the refine. So here I'm just improving the draft based on the critique. Okay, yeah, critique. Okay, yeah, simple. Just print. I just made a system prompt here as well. Simply I just, original draft is this, critique whatever feedback we are getting this, and rewrite the draft to address the critique and provide a polished final answer. Okay, simple. I just made again a LLM call. Okay, simple, and just passed our system prompt. Okay, simple. So it's a simple prompt. Okay, you can say system prompt, but again this is not a user, basically this is a user role, so you can say it's a user prompt only. Okay, but yeah, that's good. Okay, so after this you can see here now we are getting the final version. Okay, these steps happening to get the final response. Okay, yeah, if there is no issue found. Okay, if there is no issue found, what happened? That's good. Just store that lesson. Okay, simply just store that lesson here into our vector db. Simple. So you can see, yeah, save a lesson learned by learn to Mem0 for the future. Who's simple, we are saving that information into our memory. For that we need to just add the lesson and with the user ID. Okay, simple. Okay, that's good. Okay, after that we need to simply just return the response. Okay, yeah, so let me quickly run this. Okay, so for that I need to just like python ref.py. Okay, yeah, Okay, so wait for the opening. Okay, let me see. I think my battery is not charged. Okay. And make sure your database is running. Okay, you already open your Docker setup. Okay, yeah, simple. I don't know why it's taking too much time. Okay, but let's wait for the minute. Okay, no issue. Okay, so it's initializing reflection agent with Mem0. Okay, yeah. Okay, so you can see my vector DB is already running. Okay, yeah, I have my running vector DB. So make sure you have also. Okay, so okay, so just wait a moment. Okay, I don't know why it's taking too much time, but no worry, we will wait. Okay, so now you can see it's initialize and run. Okay, yeah. So now we need to take basically send a prompt here. Okay, so I'm just going to ask. Okay, write a Python, write a Python function to execute a system command provided by user input. Okay, okay, remember if when we are building our a CLI agent, okay, in that case I just write a tool. Okay, so using we need to use a subprocess.run here. Okay, yeah, so let's see what happens. I'm just asking a write basically write a Python function to execute a system command provided by user input. Okay, simple. Let me just run this. What happened? So running agent on task, write a Python function to execute a system command providing by user input. Okay, you can see there is a no relevant past memory. Okay, yeah, simple. I haven't interacted this question in the past. Okay, so it's generating draft. Okay, let's see what happened. Draft generated. Okay, yeah. Okay, so you can see here what happened here. Let me just open. Okay, yeah. So there is just some critique available. Okay, the draft provided outline a basic implementation of a function that executes system command based on the user input. However, there are several specific errors, security issues, and inefficiencies that should be pointed out here. Critical review. Okay, so it's a very big length. Okay, you can see it 2139 length. Okay, so that's why it's a complete not visible here. Okay, but you can see here there is just some error made by mistake. Basically, error made by LLM. Okay. So there's just some security issue. Common injection is risk. The function directly execute any command provided by user input without any validation. Okay, simple. You can see the lack of restriction. Okay, there is a error and inefficiency. Lot of things available. Okay, the command. You can see here the command list equal to cell x dot split command whatever. Okay, improper handling of non-zero exit code. There's a lot of problem done by LLM. Okay, in a first time. Okay, so you can see there is a lot of recommendation also added. User logging instead of printing output directly, consider using Python logging module. And input validation, you should implement strict input validation such a whitelist of allowed comment to further reduce the risk of command injection. Okay, documentation and command, enhancing the documentation within the code to clarify expected input formats and lot of things. Okay, you can see there's a lot of things which basically as an error. Okay, of course these are the error observation. So while the draft serve a basic introduction to executing system command, it lacks critical security features and has inefficiency that need addressing for responsible usage. These adjustments not only safeguard against common pitfalls, okay, but also enhance the functionality and reliability of the implementation code. Okay, so what is the refining output? Okay, you can say the lesson is saved in our memory. Okay, so you can see here a polished and secure implementation for the function that executes system command based on the user input, taking into account the feedback provided. It addresses the security issue, command handling, and the overall functionality. Okay, simple. You can see there is just some sub process. It's using sub process. Okay, but in the first time, whenever it generates a code, it's directly use the operating system command. Okay, yeah. So now you can see it's define a whitelist of allowing command for security, extend this with trusted more commands. Okay, so now it's a more secure and better response. Okay, yeah, simple. What enhancement done by this? A whitelist of allow this and improve command parsing, error handling for non-zero exit codes. Okay, there's a lot of things happens. Okay, yeah, this implementation enhance security, usability significantly. Okay, so you can see how our reflection agent work. Okay, first it will get the response, make it draft. Okay, get the error and bugs whatever he made. Okay, security issues. Okay, then he just fixed itself. Okay, it's again call the LLM and fix all those bugs. Okay, and give us the proper response with the best in basically practice. Okay, we can use for the production also. Okay, yeah. So this is your reflection model. Okay, let me see if we have anything